Spring 1943. Kummersdorf Proving Ground, Germany. Oberingenieur Klaus Reinhardt approaches a prisoner that will haunt him for the rest of his life. Not a man, a vehicle. The seized GMC rests amid the trophies of war. British Shermans, Soviet T-34s, American half-tracks. Wehrmacht engineers have tested enemy equipment for 3 years. They know what to expect. Ingenious Soviet simplicity, muscular British overbuilding, sometimes great American invention. Reinhardt surrounds the vehicle, notebook ready. 7,532 lb. 104 horsepower. Simple structure. Almost coarse. Nothing amazing. Then he removes a spark plug for standard maintenance. The threads are excellent, properly machined. He grabs for a distributor cap from another seized GMC made in a separate plant 3 months earlier, 800 miles distant. It fits perfectly. Every bolt from the engine interchanges with bolts from the chassis. Every measurement in crisp, rounded digits. He examines a third truck, then a fourth. All identical. Not similar. Identical. German autos need filing and correction even from the same manufacturing run. But these American trucks. Reinhardt demands production data from intelligence. What comes 3 days later makes him physically sick. The statistics don't bother him. They frighten him. Because this little vehicle isn't technical greatness. It's something much more deadly. The morning light sliced through the pine trees surrounding Kummersdorf Proving Ground, with that odd clarity that comes after spring rain. Oberingenieur Klaus Reinhardt strode across the testing yard, his boots leaving black impressions on the moist pavement, advancing past the familiar inventory of seized equipment that had collected since 1940. A Soviet T-34 crouched beside the main garage, its sloping armor still exhibiting the burn scars from whatever combat had halted it. 2 British Shermans waited beneath canvas coverings, awaiting their turn for full assessment. An American half-track occupied the area near the machine shop, its tracks previously removed for comprehensive measurement and study. And then there came the truck, the GMC CCKW. Deuce and a half, the Americans nicknamed it. 2.5 tons of cargo capacity. Reinhardt had read the first assessment report, captured in Tunisia, driven across the Mediterranean as a curiosity, forwarded to Kummersdorf because someone in Wehrmacht intelligence felt it could disclose something helpful about American logistics. It appeared ordinary, functional. The olive drab paint was worn and cracked. Desert dust still clung to the wheel wells. The canvas cover above the cargo bed sagged somewhat where moisture had gathered. Reinhardt circled the car cautiously, the way he had learned to approach each new testing subject. Observe first, measure second, comprehend third. The vehicle rested on 6 tires, all matching 750x20. If the sidewalls were to be trusted, the wheelbase seemed to be around 145 in. Everything in the design spoke of simplicity. No unusual alloys visible, no sophisticated mechanical systems obvious from exterior examination. The hood was flat and utilitarian. The fenders were simple steel, slightly flared. Even the grille was nothing more than horizontal slats. He opened the driver's door. It swung freely on hinges that showed no trace of wear, despite whatever rigorous treatment the vehicle had suffered in fighting in captivity. The inside was likewise Spartan. A plain bench seat, a basic dashboard with the key gauges, oil pressure, water temperature, gasoline amperage. The steering wheel was slender and basic. The gear shift rose from the floor, its pattern etched on a tiny metal plate. 5 forward gears, 1 reverse. He slid into the seat and groped for the ignition. The engine turned over on the first crank, not the second attempt, nor the third effort. After pressing the accelerator, first crank in chilly morning air for a car that had been lying idle for weeks, the inline 6-cylinder engine settled into a steady idle that Reinhardt could feel through the steering wheel and floor. He let it warm for a while, then engaged the clutch. It moved smoothly with none of the catch-and-grab behavior that hampered even well-maintained German military vehicles. First gear engaged with a clear mechanical click. He disengaged the parking brake and eased the vehicle forward. The riding quality astonished him. Military vehicles were not meant for comfort. They were designed to transport cargo over awful terrain while being maintained by troops who were not mechanics. Yet this vehicle ran easily on the testing ground's concrete, its suspension absorbing slight bumps without the hard impacts he feared. He changed through the gears. Second, third, fourth was direct drive. 5 was overdrive for highway driving. The gearbox felt accurate, confident, like equipment made by individuals who understood precisely what they were doing. Here was where military vehicles showed their real character. The GMC managed the change without drama. The two-wheel drive system meant it was not designed for harsh off-road work. That was what the Dodge WC Series and the Studebaker US6 were for. But within its design constraints, the truck performed brilliantly. The steering reacted predictably. The engine has adequate torque at low RPM to tackle gradients without extensive gear shifting. After 20 minutes of examination, Reinhardt returned to the testing yard and switched off the engine. He sat in quiet for a bit, thinking. The vehicle was nice, not outstanding nor brilliant, just firmly, competently good. Which posed a question. Why had intelligence sent it here? What were they hoping he would find? The engine room was clean, not pristine. This was a functional military vehicle, but orderly, rational. Each component was accessible. The spark plugs were prominent and simple to access. The distributor cap sat where a technician could change it in minutes. The air filter had a simple oil bath design that could be maintained by anybody with minimal training. Reinhardt grabbed for his tools and picked a socket wrench. He would start with something simple. Remove a spark plug, check the gap, study the threads. Standard approach for engine examination. The plug came out cleanly. The threads were clean and accurate. The gap was precisely as described in the documentation that had accompanied the truck. 0.035 in. He put the plug on a clean towel and picked another socket. Second plug, same situation, similar gap. Third plug, fourth, fifth, sixth. Every spark plug in the engine was built to the same rigorous quality. Not about the same, exactly the same. Reinhardt straightened and gazed across the testing yard. Another GMC waited near the perimeter fence, captured in Sicily, arriving 2 weeks earlier. Produced in a different plant according to its data plate. Pontiac, Michigan, not St. Louis, Missouri. Manufactured in December of 1942, 3 months before this vehicle. He strolled across the yard and opened the vehicle's hood, picked a spark plug at random, removed it, held it next to the plug from the first truck. They were identical. Not similar, identical. Same brand marking, same heat range, same thread pitch, same reach, same hex size. He may have closed his eyes and been unable to determine which plug came from which vehicle. He strolled back to the first GMC and performed an experiment that would have been meaningless with German automobiles. He grabbed the spark plug from the Sicily vehicle and put it into the Tunisia truck S engine. It fit wonderfully. The threads engaged easily, precisely, with the exact resistance that indicated appropriate manufacturing tolerances. No forcing, no cross-threading, no need for meticulous alignment. Reinhardt's hands were not trembling. Not yet. But something icy was developing in his chest. He went to the distributor cap, removed it, walked to the second vehicle, removed that distributor cap, pulled them together. They were interchangeable. He tried it. The cap from the Pontiac truck suited the engine from the St. Louis truck as if they had been built as a matched pair. He tested the rotor, interchangeable, the coil wire, interchangeable. Every component he checked exhibited the same unbelievable precision. He returned to his office in the testing facility's main building and sat at his desk. His notes sat open before him. He had wrote, "Utilitarian, nothing impressive" in his original review. Now he took up his pen and added a new line, then another, then another. The words came slowly because he was attempting to grasp what he had learned. This was not only a well-made vehicle. This was not even merely a perfectly made vehicle. This was something that should not be possible. Total interchangeability across factories, across time, over thousands of miles of isolation. He had witnessed German manufacturing. He has observed Opel Blitz vehicles coming off production lines at Brandenburg. Even automobiles made in the same manufacturer on the same day needed modification, filing, fitting. Mechanics kept files and hammers available because components never quite matched precisely. It was usual. It was anticipated. It was the nature of production. You constructed to tolerances, and then you adjusted during assembly. That was how things worked. Except the Americans had obviously determined that was not how things should function. They had devised a system where adjustment was unnecessary, where every part from every manufacturer suited every vehicle flawlessly, where a technician in North Africa could take a part from a broken truck and replace it in a different truck without any modification. The consequences were astounding. Reinhardt reached for the intelligence request forms. He required production data. He needed to know how many of these vehicles existed, because if the Americans could produce components with this level of accuracy at scale, then they had accomplished something Germany had never attempted, something Germany may not be capable of accomplishing. He filled out the forms carefully, specifying exactly what information he needed: factory locations, production rates, total units manufactured, component sourcing, quality control procedures, everything that might explain how the Americans had accomplished what German engineers had assumed was impossible. He sealed the request and transmitted it via channels to Wehrmacht intelligence headquarters. The answer would take days, possibly a week. He returned to the testing yard and spent the rest of the afternoon recording every dimension, every measurement, every feature of the GMC vehicle. The figures were all crisp, rounded, simple. 104 horsepower, 7532 lb, 145 in wheelbase, as if the Americans had decided that easy numbers mattered more than optimal performance. When the sun fell behind the pine trees and the spring cold returned to the air, Reinhardt closed his office and proceeded to his lodgings. He did not sleep well that night. He kept thinking about those spark plugs, those flawless, identical, interchangeable spark plugs, and wondered what the manufacturing figures would indicate when they came. The intelligence report came on a Thursday morning, 6 days after Reinhardt had filed his request. The manila package was marked with the typical Wehrmacht classifications and routing stamps, but it was heavier than he had anticipated. He opened it at his desk and started reading. The first page was a summary assessment compiled from multiple sources: aerial reconnaissance over American industrial centers, captured production documents from Tunisia and Sicily, interrogations of American prisoners who had worked in automotive factories before conscription, and analyses from German intelligence officers operating in neutral countries with access to American trade publications. The numbers started innocently enough. GMC CCKW manufacture begun in February of 1941. First-year output, around 82,000 units. Reinhardt halted and read that figure again. 82,000 trucks of one model, from one manufacturer in 1 year. He kept reading. 1942 production, 160,000 units. Projected 1943 production, based on present manufacturing capacity and actual output rates, 190,000 units. The study highlighted that these data reflected just the GMC CCKW model, without counting other American truck types such as the Studebaker US-6, the Chevrolet G7107, the Dodge WC series, or the Federal Motor Company's different variants. He proceeded to the second page, which gave comparative analysis. Total German military vehicle output across all manufacturers for 1942, approximately 78,000 units. The Opel Blitz, Germany's most successful military truck design, has produced around 100,000 to 130,000 units since 1940. Total combined output, the whole manufacturing period. The Americans were constructing more of a single truck type in 1 year than Germany had manufactured of its greatest design in 3 years. Reinhardt laid the report down and strolled to the window. Outside, technicians were completing normal maintenance on a Panzer IV. Good guys, professional men, working with equipment that was complex and effective. He observed them for a time, then returned to his desk and resumed reading. The third page covered American manufacturing procedures. This portion had been collected from interrogations and seized papers. Therefore, the material was incomplete, but key facts appeared clearly. The GMC CCKW was being built in 2 key locations: Pontiac, Michigan, and St. Louis, Missouri. Additional component production happened at dozens of supplier factories around the American Midwest. The component uniformity that Reinhardt had uncovered was not incidental. It was the whole goal of the American manufacturing system. Every component was made to standards so accurate that parts from any manufacturer fit any car without modification. This provided for various benefits that the intelligence report detailed with clinical accuracy. First, simplified logistics. Replacement parts could be supplied in bulk without worry for which exact car they would fix. A warehouse could stock one distributor cap design and know it would fit every GMC in the field. Second, decreased training time. Mechanics did not need to understand the eccentricities of various manufacturing batches. Every vehicle was practically similar. Third, speedier repair times. No filing, no fitting, no adjustment. Remove the broken part, install the replacement part, restore the vehicle to service. Fourth, economies of scale. Producing millions of identical components cost less per unit than manufacturing smaller amounts of different components. The report contained an image, somewhat blurry having been duplicated numerous times, depicting a part of the Willow Run manufacturing plant in Michigan. The caption said this was a bomber manufacturing line. B-24 Liberators being manufactured at a pace of one aircraft every 63 minutes. The facility employed 42,000 people. Most were women. Many had never worked in manufacturing before 1942, but they were making 4-engine bombers with almost 1 million parts per aircraft. The caption indicated that the GMC truck facility in Pontiac, visible in aerial images near to other GM plants, looked to be of equal scale and operated on similar principles. Reinhardt heard footsteps in the hallway outside his office. A tap on the door. He called for entrance. Hauptmann Friedrich Weber walked inside and locked the door behind him. Weber was freshly posted to Kummersdorf, moved from combat service after the North African War concluded in May. He was in his early 40s, slender and worn, with the precise motions of a guy who had learned to preserve energy in desert heat. Weber nodded to the chair across from Reinhardt's desk. "May I?" Reinhardt nodded, and Weber sat. "I heard you requested American production data. I thought you would like to hear what those figures signify in the field." Reinhardt pushed the intelligence report across the desk. Weber glanced over the first page, then looked up. "These figures are conservative," Weber stated. "I saw the convoys, Tunisia, Sicily, the final months. You could watch them for hours and never see the same cars again. Identical trucks, certainly, but different serial numbers, separate units. They simply kept coming." "Tell me what you saw," Reinhardt said. Weber slumped back in the chair. "The Americans treat vehicles differently than we do. A German battalion loses a truck, it's a problem. We take parts from broken vehicles, do field expedient repairs, keep equipment functioning much beyond its planned life since replacement is uncertain. The Americans..." He shook his head. "They abandoned repairable vehicles. I witnessed it firsthand. A GMC with a damaged axle left by the road. Not destroyed, not booby-trapped, just left since hauling up a new truck was quicker than fixing the broken one." "That's wasteful," Reinhardt said. "That's abundance," Weber corrected. "They can afford to be wasteful because they have more trucks than they need, more trucks than we can destroy. At Kasserine Pass, we struck an American convoy, destroyed about 20 trucks, seized another 15. Command assumed we had dealt major damage to their logistics. 2 days later, the same road had twice as many trucks hauling supplies. They just brought up additional vehicles." Reinhardt thought about the spark plugs, the interchangeable components. The system that Weber was describing made sense. Now, if every truck was similar and replacement was available, then repair became a simple calculation. Could this vehicle be mended quicker than a replacement could arrive? If not, drop it and go on. The system removed the cautious management that scarcity necessitated. German logistics relied on the notion that every truck was valuable. American logistics functioned on the notion that vehicles were throwaway munitions. Weber said, "The other thing you need to understand is what this does to morale. German forces know our supply condition. They know trucks are limited. They know parts are limited. They know that if anything fails, it may not be mended for weeks. American troops have the opposite experience. They break something. It's replaced quickly. They observe countless convoys of goods. They feel their industry can give anything they need, and they're correct. Reinhardt picked up the intelligence report again and turned to the fourth page. This section described component design. The GMC 270 engine was a 6-cylinder inline design with overhead valves. Displacement, 269.5 cu in. It was adapted from commercial vehicle engines that GMC had been making since the 1930s. The transmission was a Warner T93 5-speed unit, likewise modified from commercial manufacturing. The transfer case, the axles, the braking system, all of these were evolutionary improvements of previous designs rather than revolutionary new technology. The Americans had not invented new technology for this truck, Reinhardt muttered partially to himself. They had taken proven components and refined them for mass production and reliability. They're not trying to build the best truck, Reinhardt stated softly. They're trying to build the most truck. Weber agreed. Exactly. And it works. A Tiger tank is better than a Sherman in direct battle, but for every Tiger, they have 50 Shermans and 200 trucks to supply those Shermans. Tactical advantage becomes strategically irrelevant. Reinhardt turned to the final page of the report. It comprised suggestions from the intelligence office. First recommendation, Germany should strive to reverse engineer American standards procedures. Second, German industry should centralize truck manufacturing around fewer models to increase efficiency. Third, machine tool capacity should be upgraded to enable for precise manufacture at scale. Each suggestion was followed by an evaluation of practicality. The evaluations were not promising. Reverse engineering American standards would necessitate retooling the whole German car sector. Current estimate for completion, 3 to 5 years, assuming no interruption from Allied bombardment. Consolidating manufacturing around fewer models would involve discarding current tooling and retraining workers. Cost in lost output during transition, estimated at 40 to 60% loss for 12 to 18 months. Expanding machine tool capability needed raw resources Germany did not have, and time Germany did not have. The study finished with a single statement that Reinhardt read 3 times. American industrial capacity provides a strategic advantage that cannot be overcome via operational or tactical brilliance. Weber stood to go. There's one more thing you should know. The vehicles have governors, speed limiters set at 35 miles per hour. The Americans disable them. They travel at 60 or faster on supply trips. They know the engines can handle that because they trust the manufacturing quality. Our trucks done a T have governors because our engines can maintain high speeds consistently enough to require them. After Weber left, Reinhardt sat alone in his office as afternoon faded to evening. He worried about the machine tool capacity problem. Germany had competent engineers, excellent engineers, but precise production at scale needed more than technical expertise. It requires infrastructure that took years to create. The Americans had began creating such infrastructure in the 1920s and 30s during peacetime, spurred by commercial automobile competitiveness. Ford, General Motors, Chrysler, they had spent decades learning how to make millions of cars with identical parts because civilian consumers needed dependability and dealers sought easier servicing. Germany had spent those same decades creating craftsman traditions, specialized manufacture, bespoke fitting, gorgeous engineering, sophisticated engineering, but not scalable engineering. The Americans had chosen a different course, and that decision had been decided 20 years before the conflict began. The GMC truck parked in Kummersdorf's testing yard was not simply a vehicle. It was the tangible expression of 2 decades of industrial theory. And that mentality had already won the fight. Germany simply didn't know it yet. By August of 1944, the equations had transitioned from abstract production numbers to realistic combat realities. Reinhardt received intelligence reports from France with increasing regularity, each one detailing American logistical activities that should have been impossible. The Allied breakout from Normandy had happened in late July. Within 2 weeks, American soldiers were operating 300 miles interior from the assault beaches. Standard military theory maintained that such quick movement would cause a logistical crisis. Supply lines stretched beyond sustainable capacity, gasoline shortages, ammunition shortages, the final breakdown that enabled defensive troops to counterattack and recover their lines. Except the collapse was not occurring. Instead, Wehrmacht intelligence reported something unique. The Americans had constructed what they nicknamed the Red Ball Express. The name originates from railroad terminology. Red Ball freight was priority cargo that traveled on dedicated rails with no delays. The Americans had adapted this principle to truck logistics. They had designated particular routes as one-way highways allocated solely for supply convoys. Northbound routes delivered supplies ahead. Southbound routes brought empty trucks back to the beaches. No other traffic authorized. No exclusions. The intelligence summary that reached Reinhardt's desk in mid-August contained operational details compiled from multiple sources: 6,000 trucks in continuous operation, 12,500 tons of supplies delivered daily, round-trip distance approximately 300 miles, operating 24 hours per day. The study highlighted that the operation has been ongoing continuously since August 25th, with no evidence of ending. The tonnage statistics were virtually unintelligible. 12,500 tons every day equaled 375,000 tons per month. The whole Wehrmacht Eastern Front, ranging from the Baltic to the Black Sea, used nearly 15,000 tons of supplies every day, utilizing trucks, railroads, and horse-drawn vehicles combined. Reinhardt laid a map of France over his desk. The distance from the Normandy beaches to Paris was around 150 miles. American troops were now operating outside Paris, which entailed supply runs of 200 miles or more each way, 400 miles round trip in trucks going at an average speed of, he checked the intelligence estimates, around 40 km/h on French highways. 10 hours of driving each round trip, not including loading and unloading time. To sustain continuous delivery, the system needed frequent rotation of trucks and drivers. A knock on his door. Weber entered without waiting for recognition, carrying a folder of paperwork. Captured from France, he added, placing the folder on Reinhardt's desk. Operation orders for Red Ball Express units, maintenance schedules, driver rosters, the complete picture. Reinhardt opened the folder. The first document was a Red Ball Express operating order dated August 29, 1944. He reviewed the daily statistics: 5,958 trucks operating, 12,842 tons delivered, 132 different truck firms coordinated, 23,000 drivers and mechanics supporting the operation. The paper indicated this as a high day, although even ordinary days showed values exceeding 10,000 tons delivered. 23,000 personnel, Reinhardt remarked, just for one supply operation. Look at the maintenance schedules, Weber added, pointing to another paper in the folder. They're rotating vehicles through service every 72 hours. Routine maintenance, oil changes, brake inspections, tire rotations. They're treating trucks like artillery pieces, firing them continually, repairing them on time, replacing them when they fail. The whole procedure presupposes that automobiles are consumable resources. Reinhardt found the maintenance document. It specified a method where vehicles were taken from the convoy cycle in batches, maintained by mobile maintenance units, and restored to operation within 24 hours. The memo stipulated that cars needing more than 24 hours of repair should be replaced from reserve pools rather than holding up the maintenance plan. Reserve pools. The Americans had extra trucks ready particularly to replace cars under repair. The following document was a driver roster for a single truck firm. It listed 273 persons. Most were African American troops. The report underlined this because German intelligence deemed it crucial that the Americans were deploying segregated troops for logistical tasks. What struck Reinhardt was the age distribution. 3/4 of the drivers were under 24 years old. Many had notations suggesting they had gotten their commercial driving training in the Army. These were not experienced truckers. These were young guys, many from rural origins, who had never driven trucks before military duty, suddenly running the most crucial supply line in the European theater. They trained them in weeks, Weber claimed. A German logistics specialist requires months of training, because he needs to understand multiple vehicle types, maintenance procedures, field expedient repairs. An American Red Ball driver has to know how to drive one vehicle and how to follow a convoy. That's it. If the vehicle fails, someone else repairs it or replaces it. Reinhardt turned to another captured document, this one a simplified maintenance manual. It was perhaps 100 pages, spiral-bound, with illustrated diagrams showing basic procedures: oil change, drain plug location, filter replacement, refill capacity, tire change, jack points, lug nut torque, spare tire location, electrical system, fuse locations, headlight replacement, battery service. The handbook assumes no previous mechanical expertise. It considered the vehicle as a closed system, where certain operations could be performed by anybody following instructions, and anything beyond those processes should be directed to specialist personnel. He likened this conceptually to German vehicle maintenance documents. The Opel Blitz handbook comprised almost 600 pages and covered many car models manufactured over several years. It believed the technician knew automotive fundamentals and could detect faults via observation and testing. It provided precise instructions for adjusting components, fitting parts, accounting for production variances. The American handbook assumed the vehicle will either function properly or not work at all, with no between ground needing professional modification. "There's something else," Weber added. He took out a war report from a panzer unit that had fought American supply convoys in early September. "We captured several functioning GMC trucks. Our mechanics started fixing them using parts from other confiscated cars. A Chevrolet engine component fit a GMC chassis mounting point. A Dodge electrical connection worked with GMC wiring. The Americans constructed their whole vehicle fleet with cross-compatibility." Reinhardt had not considered this. The interchangeability he had observed within a single truck model seemingly extended across multiple manufacturers. General Motors, Chrysler Corporation, and other American car businesses had coordinated their military manufacturing to achieve maximum parts commonality. A battlefield mechanic working with seized American trucks could mix and match components from several truck kinds, since the whole system had been intended for interoperability. "Our soldiers prefer driving captured American trucks to our own vehicles," Weber stated. "The crews report better reliability, easier maintenance, more comfortable ride quality. We have incidents of German soldiers leaving Opel Blitz trucks in working shape to utilize seized GMCs instead." The implication was devastating. German soldiers, given the choice between their own nation's equipment and captured enemy equipment, chose the enemy's, not because American trucks were technologically superior, they were not, but because they were systematically superior, easier to operate, easier to maintain, more reliable, more available. Reinhardt uncovered another paper in the folder, this one an intelligence estimate of American automobile manufacturing until mid-1944. Total military vehicles built by the United States since 1940, nearly 2 million units. Current manufacturing rate, around 200,000 trucks per month among all manufacturers. For contrast, Germany had manufactured around 347,000 military vehicles over the whole conflict across all manufacturers. The Americans were constructing more vehicles every 2 months than Germany had constructed in 4 years. "The numbers are worse than we thought," Reinhardt remarked. "The numbers don't capture what it feels like in the field," Weber answered. "You destroy an American convoy and it's replaced the next day. You seize American vehicles and they stay working because your technicians can maintain them better than they can service your own equipment. You cut a supply route and the Americans just develop another path. There's no stopping it. There's no interrupting it. The logistical system has greater capacity than we have capabilities to attack it." Reinhardt closed the folder and looked at the map of France still spread across his desk. The red lines designating American advance routes appeared like arterial blood flow, each advance backed by thousands of vehicles bringing supplies ahead in continuous streams. The Wehrmacht had gained tactical triumphs during the summer. German forces had battled well, caused losses, slowed American assaults. But none of it mattered. The trucks kept arriving. The supplies continued pouring. The American push persisted, not because German resistance had failed, but because American logistics rendered withdrawal the only realistic German choice. "There's one final detail," Weber added. He pointed to a note in the operation order. "The Red Ball Express is not the only supply operation. There are smaller convoy systems, rail operations, air transport, and coastal shipping. Red Ball is only the immediate reaction to the breakthrough. It's what the Americans produced in a few weeks when standard supply networks could not keep pace with their own growth. This whole system, 6,000 trucks, 23,000 staff, 12,000 tons each day, is their makeshift backup plan. Reinhardt thought what the fundamental plan must look like. If Red Ball was the emergency backup, what capacity did the typical American logistics system possess? He thought of the GMC vehicle waiting at Kummersdorf's testing yard. That truck represented one unit in a manufacturing run that now numbered in the hundreds of thousands. A single vehicle that had traveled from Michigan or Missouri to a North African battleground to a German testing facility, and it still worked properly. Multiply that dependability by 500,000 trucks. Multiply such interchangeability by millions of components. Multiply the output capability by dozens such plants. The outcome was not a military force. It was an industrial landslide that buried everything in its path via sheer accumulated bulk. The entire evaluation reached Reinhardt's desk in late October of 1944, prepared by Wehrmacht intelligence after months of study. The cover brief advised that the accompanying data reflected worst-case scenarios based on verifiable observations rather than speculative guesses. Reinhardt opened the report and started reading. Within 3 paragraphs, he recognized that worst case was really simply case. There was no hopeful interpretation of these figures. American military vehicle production from 1940 to September 1944, 2,485, 964 units. The study divided this down by category: military trucks of all types, 2,400,000 units, jeeps, 650,000 units, half-tracks, amphibious vehicles, and specialized carriers, hundreds of thousands more. The GMC CCKW alone accounted for 520,000 to 560,000 units, depending on whose manufacturing statistics were regarded most accurate: one truck model, one manufacturer, more than the whole German military vehicle output across all manufacturers for the entire war. Reinhardt went to the comparative analysis section. German military vehicle production from 1939 until September 1944, 347,490 units. Primary models: Opel Blitz at over 130,000 units, Mercedes-Benz L3000 at roughly 80,000 units, and several other manufacturers manufacturing lesser amounts. The ratio was strikingly clear. For every German military vehicle manufactured, the Americans had produced 7 trucks. In 1944 alone, American manufacturing equaled Germany's total war output. But the study noted that raw figures represented just half of the picture. The following section described availability rates. American trucks, 80 to 90% operational availability. German trucks, 60% operational availability under good conditions, often less than 40% in battle zones, owing to component shortages and maintenance delays. This means the effective ratio was not 7.1 but closer to 10:1. An American unit with 100 trucks on inventory may anticipate 85 to 90 vehicles functioning at any moment. A German unit with 100 trucks may anticipate 50 to 60 operating vehicles. The strategic implications section made plain what Reinhardt had been pondering for months. American troops may absorb vehicle losses that would impair German operations. Destroying 1,000 American vehicles was strategically insignificant. The Americans built more than 1,000 trucks per day. They could sustain such losses without any modification to operations. German soldiers losing 1,000 vehicles faced imminent operational difficulty. Replacement vehicles did not exist. Units would be immobilized. Supply operations would fail. The asymmetry was absolute. Reinhardt discovered Weber in the testing yard studying a freshly seized American Studebaker US-6. "You need to read this," Reinhardt remarked, giving him the report. Weber glanced through the first few pages, his face unwavering. He had seen enough military realities not to be astonished by numbers anymore. "There's a Panzer Commander report in the annexes," Weber stated. "I read an advance copy. You should discover it." He gave the paper back and went to studying the Studebaker's suspension system. Reinhardt walked back to his office and discovered the annex portion. The report was dated October 15, 1944, from a Tiger Battalion commander whose identity had been deleted. The evaluation was clinical and dismal. We can destroy their tanks, the report claimed. A Tiger attacking Shermans at range enjoys tremendous tactical advantage, but we cannot eliminate their logistics. For every Tiger we field, the Americans field 50 trucks. Those trucks carry gasoline, ammo, and new tanks quicker than we can destroy them. Tactical advantage becomes strategically irrelevant when the adversary can sustain losses forever and we cannot. The study continues with concrete instances. In a recent combat, the unit had destroyed 17 Sherman tanks. The Americans retreated, reorganized, and returned 12 hours later with more tanks than they had lost. German troops who lost 17 tanks would require weeks to get replacements, if replacements existed at all. The underlying equation was unsolvable. German tanks were superior. German tactics were superior. German crews were more experienced. None of it mattered when the Americans could replenish losses overnight and Germany could not. Reinhardt proceeded to the next section, which addressed the Ardennes operation being planned for December. The strategy believed German troops could seize American gasoline depots since German logistics could not provide adequate fuel for continuous tank operations. The idea entailed utilizing seized American fuel to keep German panzers forward. The strategy recognized that German trucks could not maintain the delivery rates essential for success. The whole operational approach was founded on desperation. Assault with what you have, maintain the offensive with what you acquire, pray the adversary breaks before you run out of seized supplies. He wondered about what it meant. The Wehrmacht was preparing a big attack, based on the notion that American logistics were so numerous that seizing enemy supply was more dependable than pushing forward German supplies. The strategy accepted defeat before the combat began. It confessed that German trucks could not compete with American trucks, that German supply systems could not equal American supply systems, that the only way to success was taking American success. The report featured images acquired by reconnaissance planes over American rear locations in France. Reinhardt investigated them with a magnifying glass. Enormous supply depots sprawled over former agricultural fields. Thousands of cars parked in regimented rows, piles of goods covered with tarps, gasoline tanks packed along train lines. The immensity was tough to understand. One shot shows an estimated 400 vehicles in a single facility. The caption said this was a backup motor pool, not a key logistical base. 400 vehicles kept in reserve. Germany would consider 400 trucks adequate to supply a corps. The Americans regarded it a reserve pool for one section of one front. Another shot showed a port facility, probably Cherbourg based on the geographic features. Ships unloading goods straight onto trucks, cranes transporting supplies from holds to waiting vehicles in continuous operations. The intelligence evaluation suggested this one port was processing 8,000 tons every day. Germany's whole rail network, running under incessant Allied bombardment, struggled to transfer 15,000 tons per day across all fronts. Reinhardt discovered the last assessment part. It was brief. American industrial capability provides an overwhelming strategic advantage. Current German output cannot be boosted significantly to attain parity. The Allied bombing campaign methodically degrades existing German capability. No operational or tactical brilliance can overcome a 10-to-1 material imbalance that becomes bigger each month. He closed the report and sat in quiet. The afternoon sun slanted through his office window, revealing dust motes in the air. Outside, mechanics were repairing a Panther tank. Excellent guys maintaining excellent equipment. The Panther was a superb tank, probably the greatest medium tank in the world. Germany had manufactured around 6,000 Panthers. The Americans had manufactured 49,000 Shermans and 2 million vehicles to supply those Shermans. Weber came at the doorway. I thought you should know the GMC in Bay 3 just logged its 500th hour of testing operations. Original engine, original gearbox, no significant repairs necessary. We have Opel Blitz trucks that require overhauls after 300 hours. Reinhardt nodded slowly. 500 hours of continuous operating on a vehicle that had already experienced combat duty before capture. The truck was still operating on components built in Michigan or Missouri in early 1943, nearly 2 years of duty, several theater transfers, capture, extensive testing. and it still performed reliably enough to satisfy Wehrmacht assessment criteria. "There's something else," Weber added. He entered the office and closed the door. "I received a letter from a colleague still in the field. His crew grabbed numerous GMC vehicles last week, operational condition. They're utilizing them for supply trips since they're more dependable than our own vehicles. But here is the element that matters. The serial numbers on those vehicles are in the 6 million range." Reinhardt felt something chilly settle in his chest. 6 million? "Serial number 6423-817, Weber stated. "That's what my colleague reported. The Americans are stamping serial numbers that high because they've created that many vehicles, not just trucks, all military vehicles together, 6 million units." Reinhardt grabbed out a notepad and performed the calculations. 6 million automobiles manufactured in about 4 years. That was 1.5 million vehicles per year, 125,000 vehicles per month, 4,000 vehicles per day. Every day, Saturdays, Sundays, holidays, 4,000 military vehicles rolling off American production lines every 24 hours. Germany's whole war output of trucks was 347,000 units. The Americans manufactured that many automobiles in 3 months. "We're not testing enemy equipment anymore," Reinhardt remarked softly. "We're documenting the weapon that defeated us." Weber said nothing. There was nothing to say. The maths were absolute. The Americans had not triumphed through tactical genius or technical supremacy. They had triumphed via methodical industrial capacity created over decades of peacetime manufacture. They had triumphed because Henry Ford had established the assembly line 30 years previously, and American industry had spent those 30 years mastering mass manufacturing. They had triumphed because basic trucks built by the hundreds of thousands defeated complex vehicles manufactured by the tens of thousands. They had prevailed because, in contemporary conflict, the system always defeats the genius. Reinhardt opened his testing journal and wrote the day's results. The GMC CCKW remained functioning after 500 hours of testing. All systems working within permissible boundaries. No major deterioration noticed. He dated the entry October 28, 1944, and closed the log. Tomorrow he would resume testing. He would document specs. He would measure tolerances. He would prepare reports. But the ending was already written. Germany had lost the war when the first GMC went off the manufacturing line in February of 1941. Everything since then was about calculating the cost. The evacuation order for Kummersdorf came in early April of 1945. Soviet troops were approaching from the east, and Wehrmacht sites around Berlin were being methodically abandoned or destroyed to avoid capture. Reinhardt spent his last days at the proving field compiling documents, prepping equipment for shipment or disposal, and ensuring that nothing of intelligence value would slip into enemy hands. The seized vehicles would be destroyed. The testing equipment would be destroyed. The buildings would be abandoned to Soviet possession. 4 years of labor reduced to ashes and vacant buildings. He strolled through the testing yard one more time on a cold spring morning. The GMC truck remained sat where it had been parked for much of its stay at Kummersdorf. Mechanics had maintained it working during the testing period, using it periodically for utility work around the complex when German vehicles were unavailable. The odometer now indicated almost 15,000 miles accumulated during capture, transfer, and testing. The vehicle ran as smoothly as it did the first morning Reinhardt had fired its engine. He went into the truck and sat in the driver's seat, hands on the steering wheel, peering through the windshield at the proving ground he would never see again. The German engineering philosophy has created masterpieces. The Tiger tank was a masterpiece. Superior armor, superior firepower, superior design. Germany had constructed 1,347 Tigers, including the Tiger I and Tiger II types combined. The Americans had manufactured 49,234 Sherman tanks. Not better tanks, but adequate tanks, sufficient in overwhelming number. The same concept applied to the vehicle underneath him. Not the greatest vehicle, but a good enough truck built in numbers that rendered best redundant,